We all love driving fast along a highway where there is no traffic. However, at times, we just want to enjoy the quiet countryside riding slowly on our bikes. So the terms that we use to indicate motion that is fast or that is slow are speed and velocity. Speed is a measure of distance covered in unit time, whereas velocity is a measure of displacement in unit time. And therefore, speed would be equal to distance upon time, whereas velocity would be equal to displacement upon time. Now, since distance and displacement, both of these quantities are measured in meters, the SI unit of both speed and velocity would be meter per second. Now let's understand both these quantities, speed and velocity, using some examples. Now in our first example, we take the path ABC in 5 seconds. Now here the distance covered is 70 meters, so the speed would be equal to 14 meters per second. And the displacement is 50 meters, so the velocity would be equal to 10 meters per second. In our next example, we take the path from A to B to C to D, and we cover that path in 8 seconds. So the distance is 100 meters, and therefore the speed would be equal to 12.5 meters per second. Now here the displacement is just 40 meters, and therefore the velocity would be equal to 5 meters per second. Now from both these examples, it is clear that velocity will always be lesser than or equal to speed. In our next example, we start from A and go around B to C to D and then come back to A, and we do that in 10 seconds. Now here, since the distance covered is 140 meters, the speed would be equal to 14 meters per second. And since we returned back to our original position, the velocity would be equal to 0. And in our next example, we start from A, go around B, C, D and then go to E. And we do that in 13 seconds. Now here, the distance covered is 190 meters, and therefore the speed is equal to 14.6 meters per second. And the displacement is negative 50 meters because it is in the opposite direction, and therefore the velocity would be equal to minus 0.4 meters per second. Now from this example, it is also clear that velocity can be negative, and it is negative because it has got a direction, and therefore velocity is a vector quantity whereas speed is a scalar quantity. So you may say S for speed and S for scalar, and V for velocity and V for vector. So now let us look at a problem that involves these concepts. A biker starts from Rajkot and travels along a long straight road to Ahmedabad, located 216 kilometers away. If he reaches Ahmedabad in 3 hours, what is his average velocity in SI units? So we know that velocity is equal to displacement upon time. Our intuition says that average velocity would be equal to total displacement upon total time. So in this case, the total displacement is 216 kilometers and the total time is 3 hours. So when we replace the values, we get the average velocity as 72 km per hour. But we need to convert this into SI units. How do we do that? To convert kilometer per hour to meter per second, as you learnt in your lower classes, you need to multiply kilometer per hour with 5 by 18. and 72 km per hour would be equal to 20 meter per second. So assuming that the biker traveled at 20 meter per second, he would travel 100 meters in 5 seconds. And this could happen in two ways. In the first instance, the biker travels 20 meters in the first second, another 20 meters in the second, another 20 in the third, another 20 in the fourth, and another 20 in the fifth second. So the biker covered equal distances in equal amounts of time. So we can say that this is an example of uniform motion. Now there's another way in which the biker could travel 100 meters in 5 seconds. In the first second he covers 10 meters and then 20 meters and then 40 meters and then 20 meters and then again 10 meters. So the biker did not cover equal distances in equal time units. And this is an example of non-uniform motion. Now in non-uniform motion, the biker is sometimes fast and sometimes slow. This is how it is indicated in the speedometer of the bike. The speed is sometimes high and sometimes low. And the speed that is indicated in the speedometer is the speed of the bike at that particular instant, and that is called instantaneous speed. And if the biker is moving along a specific direction, it is also called instantaneous velocity. So in uniform motion, the instantaneous velocity of the biker throughout the 100 meters remained 20 meters per second. So in uniform motion, the instantaneous velocity remains constant. However, if you look at non-uniform motion, the instantaneous velocity kept on changing throughout those 100 meters. So in non-uniform motion, the instantaneous velocity does not remain constant. And now, the summary of this video. Speed is distance covered in unit time, whereas velocity is displacement in unit time. Velocity is always lesser than speed. It can be zero and it also can be negative. And therefore, speed is a scalar quantity, whereas velocity is a vector quantity. In uniform motion, a body covers equal distances in equal amounts of time. And we can say that in uniform motion, the instantaneous velocity of a body remains constant. So in uniform motion, it is also essential for the direction to be constant. So that's all in this video. In the next video, we will look at one more way of describing motion, and that is when we describe accelerated motion.